this video, we're going to be going over the 7.3 guided practice problems solving radical equations. So the big thing in this section as far as steps go is we first want to isolate the radical, or if we are given a fractional exponent like on number 4, then we want to isolate the base that's attached to that fractional exponent. So isolate the radical or the base. So our radicals on the first one, there's actually 2 of them. So here and here, radical right here, cube root right there. And then this is the base that's attached to that exponent. So that's always going to be our first step, is isolating the radical or the base. And step 2 is to power up by the index if it's a radical, and by the reciprocal power if we are dealing with a base raised to a fractional exponent. So those are only 2 main steps, but then our third step is we must check for extraneous solutions. Now, there will be some cases where you can kind of see the extraneous solution scenario arise, kind of those red flag areas as you are working through the problems. But there's other cases where it's only by plugging in and checking at the end that you'll be able to identify them. So let's go ahead and just start with this first problem. So we've got the square root of 3x plus 12 and the square root of x plus 8. So our radicals are both already isolated. So to get rid of them, we are going to power up both sides by 2 because that is the implied index of a square root. So when I power up by 2, goodbye radical number 1, goodbye radical number 2, and we get 3x plus 12 equals x plus 8. So now we've got just a ground level algebra 1 equation. So to solve it, we want to get all of our x's onto one side. So I'm going to subtract this x to move him over. And then we will subtract 12, moving our constants over to the other side. So that gives me 2x equals -4, and x is equal to -2. But we're not going to put a box around it because I have to check to make sure that this works in both parts of the equation, giving me a true statement. So when I plug -2 in, -2 times 3 is -6, and -6 plus 12 is 6. So on the left side, when I plug in, I get radical 6. When I plug this in on the right side, -2 plus 8 is 6. And I get radical 6 equals radical 6. That is a true statement. So that means x equals -2 really is my solution. So this is my check. You do not have to show that check work. I find it helpful to write it down. You just need to make sure that you're doing it for every single problem, or you're able to identify those red flags along the way. So folks, let's go ahead and take a look at number 2. So on this one, what will I need to do to isolate the radical? Well, I've got this 4 that's being added in front, so I'm going to need to subtract 4 to move him over to the other side. And that gives me the square root of -3m plus 10 equals m minus 4. So now my radical is completely isolated on the left side. I can't subtract things out of the radical. So we are ready to power up by the index. So the index of this radical is 2. So we're going to power up both sides by 2. Now, notice that I'm enclosing this in parentheses. This is very important and one of the more frequent mistakes that students make on this section. When I power that up by 2, we have to FOIL it because m minus 4 squared is m minus 4 times m minus 4. A lot of times students will mistakenly try to use their power rules and distribute that power and saying it's m squared minus 16 or m squared plus 16. But when I am squaring a binomial, I have to multiply it by itself, which lends itself to FOILing. So I always say, when in doubt, expand it out. M minus 4 times itself, I write that parentheses twice. On the left side, our radical goes away. So -3m plus 10. So now let's actually carry out our FOILing we get m squared minus 4m minus another 4m, and then plus 16. Now, at this point, what should be on your radar is we've got a quadratic term on the right side, and how we solve quadratics is we're going to have to factor it and set it equal to 0. So when you see a quadratic term, we want to set it equal to 0 so that we can use the zero product property and factor to solve. So folks, I'm going to try to keep that m squared term positive, and I'm going to move everybody else over to the right side to get it to be equal to 0. So plus 3m minus 10 minus 10, and we get 0 equals m squared. Let's see, minus 8m plus 3m is minus 5m, and then we get a plus 6. So now it is equal to 0, so we want to try to factor it. So we're looking for a product of 6 and the sum of negative 5, so m minus 2 and m minus 3. That gives me positive 6 for the product and negative 5 for the sum. Then set m minus 2 equal to 0, m minus 3 equals 0, m equals 2, m equals 3, but wait, there's more. So we have two potential solutions, but we do need to check by plugging back into our original equation. So let's go ahead and plug in the 2 first. So that would give me, let's see, negative 6, and then plus 10 is 4. The square root of it is 2, and then 4 plus 2 is 6, and then that gives me 2 on the right side. So that's the left side of the equation, that's the right side of the equation. So that is a false statement, which means that is an extraneous solution. So I show that I solved for it, but it doesn't actually work when we plug it back in. Then for our 3, we get negative 9 plus 10 is 1. Square root of 1 is 1. 1 plus 4 is 5. And 5 does not equal the 3 on the right side. So folks, that one doesn't work either. So I get 2 extraneous solutions, which means the final answer to this problem is no solution. So if both, or if this one had just ended up being extraneous, if none of the potential solutions work, then it ends up being no solution for the problem. So folks, moving on down to this one. To isolate our cube root, we're going to subtract 1. Making sure you still write that index. And then we're going to power up by the index, which this time we power up by 3. And for whatever reason, sometimes students will rush this and say that they get 9 on the right side, but this is 3 to the third, not 3 times 3. So 3 to the third is 27. The cube root cancels out the cubing, and x is 27. Now, we still need to check ourselves by plugging back in. So the cube root of 27 is 3. 3 plus 1 is 4. 4 equals 4 is a true statement. So x equals 27 really is our solution. So you can encounter quadratics that require factoring. You can encounter simple ground level algebra 1 equations. A lot of the mistakes that get made, though, are here, where students multiply instead of actually powering up, just because we're more used to doing those operations. Powering up is new for us in this unit, so it is kind of an easy mistake to make. And then distributing the power when we have to FOIL. So moving on to our last type of problem. Let me go ahead and kind of box this off. There we go. Our first step is going to be isolating this base being raised to that fractional exponent. So there's 2 things we have to get rid of: the timesing by 3 and the adding 4. So we have to subtract the 4 first. So that gives me 3 times x minus 1 raised to the 2/3. That gives me 48. Then sometimes students will try to distribute that 3 into the parenthesis. It would make it easier, but it would be wrong. So the reason we can't distribute that in is because PEMDAS says we have to handle that exponent first. So instead of distributing that 3 in, we have to divide it away. Our whole focus here is to try to isolate this part that's being raised to that exponent. So we divide both sides by 3. And x minus 1 raised to the 2/3 equals 16. Now, here, there's a couple of different ways you can think about it. So if I think about the root power, it would be x minus 1 to the 1/3 and then squared. So how would I get rid of the 1/3 power or cube rooting something? We would cube sides. But then how would I get rid of the squaring power? We would have to square root both sides. So to get rid of both of these issues at the same time, we're actually going to power up by the reciprocal power. So I'm going to power up both sides by 3/2. So then the 3's cancel, the 2's cancel, and I'm left with x minus 1 equals, now over here, we're going to use the strategies that we outlined in 7.2. Yeah, you could type it in on your calculator, but let's go ahead and break it up into the root power, which is the 1/2, and then cubing it. So the square root of 16, and then cubed, so the square root of 16 is 4, and then 4 cubed is 64. I'm running out of space. So then that x minus 1 keeps traveling down, and we end up getting x equals 65. So to check this one, we plug into the original equation, and 65 minus 1 is 64. The cube root of 64 would be 4. 4 squared would be 16. 16 times 3 is 48, and 48 plus 4 gives me 52. So we get 52 equals 52. True statement. So x equals 65 is our final answer. And folks, if you're still a little bit unclear on this, of course you can double check yourself on your calculator, but I would expect you to be able to show that work, since you'll have to do that for the 7.2 learning target as well. That concludes the 7.3 guided practice.